Now that you know how to write a vector, how to determine a vector, of a given if it's a vector or a magnitude or scalar quantity, then the next step for us is to operate this vector. How do we operate them? How do we add a vector? How do we subtract a vector? How do we multiply and divide a vector? And also, there are two types of vectors. Uh, the first one that we discussed in the previous video, we call that one the position vector. A position vector. A position vector is a vector that starts at the origin and it ends to a certain point. That's why it's called position vector or point vector also. We can also call it a point vector. And there is another one, the directed vector. Directed, or they also call this one the displacement vector. The directed vector or displacement vector, this starts from a point, not the origin, and ends to another point, not the origin again. So it's called directed vector. And we will be dealing examples for these two type of vectors in this video. But first, we need to discuss what are the characteristics of a vector of vectors and how do we add them or subtract vectors. So first, how do we add a vector or subtract a vector? Vector can be added and also subtracted. So if we have two vectors, let's say, I just write here two vectors, let's call it vector A and the other one vector B. So let's say the vector A is has a components AX in the X direction, in the Y direction, and AZ in the Z direction, while for B, let's just call it BX. For B, for the components of this vector. So these are two vectors. Now let's try to apply the operations for these two vectors. So number one, adding and subtracting. Add or subtract. So how do we add? How do we subtract vectors? So what will be A plus or minus B? So here, we just copy this one. So this is the component form of vector A. Then we need to add this with, so plus the component vector of vector V. So plus this one here. Just put it here. So to add them, we can only add, remember this, we can only add vectors at the same directions. So for example, here, A and B, they don't have the same direction, but we can add them through their components that has the same directions. For example, AX and AX, they have the same direction, this component in the same direction, this component in the same direction. So if we add or we subtract, so plus or minus, this is plus or minus, let's put a quantity here, plus or minus, so the result will be AX plus BX, that will be AX plus or minus BX. And these two is in the X direction, AX. So we just add the components. The components were has the same direction. So AY plus or minus BY. In the Y direction, and also plus or AY plus AZ plus or minus BZ, and this time this is in Z direction. So this will be vector A plus or minus vector B. So that's how we add vectors. We add vectors in the same direction. We just add the components in the same directions. So the vectors, if the two vector has the same direction, then you can just add directly the magnitude of the vector, and the direction will be, it's still the same direction as the direction of the two. there's a property of a vector. It is considered associative. Associative. It is also considered distributive. We can also distribute. And also, it is commutative. So these laws all applies to vectors. Commutative. So what does this mean? Associative, if we have two vectors or three vectors, A plus B plus C. So if we group this is the same as A plus B plus C if you group these two first. Also, it can be distributive if you have a constant K and you have two vectors. So these are all vectors. This is a constant. This is a constant. Then you have two vectors that we want to add. Then, because this is, we can apply distributive property to vectors, so we can distribute that K. So this will be equal to K times vector A plus K times vector B. And A plus B is also the same as B plus A. So these are the property. You can do this one into the vectors. Also, it's not just the constant that can be distributed. You can also distribute the vectors if you have two constant. If you have two constant, K1 plus K2, if these are constant, then you have a vector A here. You can still distribute that vector. So this will become K1A times vector A plus K2 times vector A. But if the vector inside is 2, or there are two vectors inside, then another vector here, then you distribute that vector. Now it depends on what multiplication that we will be using, because in vector operation there are two type of products that we will be dealing. So you cannot just multiply them based on what you want. So it depends on the operation. So we have two types of products. The first one, we call it the dot product. Dot product. This is also called the scalar product. It's called the scalar product because the output or the end result of this product is a scalar quantity. So what is a scalar quantity? Again, this is a quantity that has no direction. It's just the magnitude. So how do we do that product? So the symbol for that product, so if you have two vector A, the symbol is just a dot. That's why it's called dot product times B. This one, this is read as A dot B. And we can solve this by taking the magnitude of A, then you multiply it with the magnitude of B. So how do we solve this magnitude? We already discussed this in the first video. Then you multiply this with the cosine of an angle theta, where theta is the smaller angle between vectors A and B, between A and B. So because these are vectors, so there's angle between them. And the smaller angle, that will be theta. You take the cosine of that, you multiply it with the product of the magnitudes of the two vectors, then you get the dot product. So if you look at this formula, the output here, this is just a number because A is a number, it's just a magnitude, B is just a magnitude. You take the cosine of a certain number, it's also just a number, a magnitude, you multiply them, then it's just a number, it's just a magnitude. So it's a scalar quantity. So if we apply this, if this is given, we have two vectors here, A and B. we take the dot product between the two. So let's try to do that. A dot B. A dot B. So I'll copy A here. So this is equal to this. Then I'll copy B. Then we take the product of these two. Let's put the quantity here and quantity here. And dot product. Then to do the multiplication, we can use a distributive property, the FOIL, just like that. You can multiply that and so on. And also this one, and this one, and this one. Later on, we will be deriving this formula. But later on, you don't need to do this every time you take the dot product of two vectors. We only do this one here for the derivation of the formula. So let's do this. First, AX dot BX AX. Then we have plus AX dot BY AY. Then plus AX dot BZ AZ. So that's the first one. Second one, so plus AY dot BX AX plus AY dot BY AY plus AY dot BZ AZ. And lastly, for the AZ, plus AZ dot BX AX plus AZ dot BX or BY dot BY AY. Then lastly, AZ dot BZ AZ. Then we apply the definition of that product. You take the magnitude, then you take the cosine. So first, this product here. So there are two vectors here, AX and BX AX. So what are the magnitude of the two? It's AX times BX. So let's take the magnitude. The magnitude is AX. You multiply them. So this will be AX times BX. Then you multiply the cosine of the angle between them. So what's the direction of AX? AX. So it's in the X direction. What's the direction of BX and AX? It's also in the X direction. So if they have the same direction, what is the angle between them? So the angle between them is 0. Because they have the same direction. They are in parallel with each other or in the same line. So meaning the angle is 0. So if you take cosine of 0, what will be cosine of 0? Cosine of 0 will be equal to 1. Then to the second one, here, let's repeat that again. This will be AX BY. Then this time, AX dot AY. So remember our drawing in the previous video, the direction of AX, AY, and AZ. So if this is the rectangular coordinate system, this was our AX, here is our AY, and the upward direction is our AZ. And what's the angle between all these three? They are all perpendicular to each other. Perpendicular all to each other. So here, AX dot AY. So what's the angle between AX and AY? So this is the angle between them. And that angle is perpendicular, so it's 90 degrees. So this will be cosine of 90. So what will be the cosine of 90? The cosine of 90 is 0. So we can conclude that if we take the dot product of uh, unit vectors in a different direction, then the answer will be always be equal to 0. So for example, here, if I take AX, I dot this one with AY, because the angle between these two is 90 degrees. Cosine of 90 is equal to 0. So the answer is 0. I don't care about the magnitude, because the magnitude here is 1, because there are two unit vectors. 1 times 1 is 1. And you multiply it with cosine of 1, cosine of 0, or cosine of 90 is 0. So it's still equal to 0. Also, if you have AY dot AX, if you take the other way around, it's still equal to 0. AY dot AZ. How about AY dot AZ? This is also equal to 0, because the angle between y and 0 is 90 degrees. And we can also inverse this. AZ dot AY is also equal to 0. And lastly, AZ dot AX. And again, this is equal to 0, because the angle is also 90 degrees. As long as the directions are different, then it's always equal to 0 if we talk about these three unit vectors. Now, if they have the same direction, so AX dot AX, then this will be equal to 1. Why? Because the angle between AX and AX is 0. Cosine of 0 is 1. Times the magnitude is 1. 1 times 1. Also, AY dot AY, this is also equal to 1. And lastly, AZ dot AZ also equal to 1. So if we go back here, we can now simplify that. We can make all the products here that has AX, AY, or different direction to be equal to 0. So for example, this one is 0. AX dot AZ is also equal to 0. AY dot AX is again 0. And this one, AY dot AY, it's the same direction. So this will be equal to 1 times AY times AY. So this will be AY times BY. This one is 0, AY AZ. AZ AX is 0. This one is also equal to 0. But this one, AZ dot AZ, is not equal to 0. It's equal to 1. So this will become AZ BZ. So we have now our formula for the dot product of the two vector. A dot B now will be equal to what? AX BX. So we have AX BX. Then plus, we have AY BY. So plus AY BY. Then lastly, we have AZ BZ here. So plus AZ BZ. So here, just like what we did in addition and subtraction of vectors, we did add the magnitude of the components in the same direction only. Here in that product, we also multiplied the magnitude of the component in the same direction. AX and BX, these are the components, the magnitude of the components of A and B. But this time we remove the direction, because this is a scalar product. Our output should be a scalar quantity. So this is that product. And the last one, the last type of product, we call it the cross product. Cross product. And this cross product is also called the vector product. Vector product, because the output of this product is a vector quantity. It's different from the dot product. So A cross B. So this will be the definition. A cross B. So the symbol will be crossed here. So we read this one as A cross B. This is now equal to the magnitude of A multiplied by the magnitude of B. But this time we use sine instead of cosine, sine of the angle. But if we do this one, the output is just a scalar quantity. So we need to put a direction here, A. And that A is a unit vector A cross B. The direction of A cross B. Then how do we determine this direction? And again, theta here is the smaller angle between A and B. And this small a here is the unit vector normal to the plane. This is the unit vector normal. So what do we mean by normal? It means perpendicular. Perpendicular to the plane where where we are taking the dot product between A and B. So for example, if you have here, let's take so if we have two vectors at the xy plane. So this is x here, and this is y here. So we have vector here, vector A, and this vector here, vector B. So if this is vector A, and this is vector B. So if you take the cross product of A and B, the direction of the cross product will be in perpendicular with this plane, A and B here, which is the x and y plane, if the direction here is in the xy plane. So obviously the direction will be, it can be upward or it can be downward if A and B is along the xy plane. Okay, but what will be the result? Is it upward or downward? So if we are taking A cross B, so A cross B, remember this, is not equal to B cross A. This is not true. It can only be true if you put here a negative. What does this mean? This means it's the opposite direction. The negative means it's in the opposite direction. They have the same magnitude, but they have opposite direction. So if we're taking A cross B, the direction of A cross B will be if A to B. So that is counterclockwise. So the direction of A cross B will be in this direction. This will be A cross B. To remember this, you can use your screwdriver or your screw, just a screw. So if you have a screw, imagine this is a screw here, a negative screw. So this is a screw. Now if you want to push the screw downward, so how do we rotate that screw? So we need to rotate it in the clockwise direction. And just like cross product, if you rotate it into clockwise direction, then the direction of the cross product will be the same direction as the screw, which is downward. But in this case, if you are taking A cross B, so we are in counterclockwise. So this screw, what will be the direction of the screw? It will lose, so it will go upward. So that's a way of remembering this cross product, A cross B. And here will be, this will be negative A cross B. If you go downward, then the magnitude is just equal to this one, A times B times sine the angle between them. So now how do we take the cross product of these two? So let's take again our example here. These two here. But this time we use that product. So I'll just copy this. Then put it here. So A cross B. So the arrangement is important. Then instead of dot, this should be cross. Then we can again distribute just like what we did in the dot product here. And we can just copy this again. And we just need to change those dot with a cross. But make sure that we are doing the right arrangement. We start with A and we end with B. So let's make them all crossed. So this is cross product. This is cross product. Cross product. Cross product. Cross. And so on. Now, what is AX cross AX? So if we cross the unit vectors, because it all goes down to the unit vectors when we simplify this. So what is AX cross AX? So go back to definition. 1 times 1, that's the magnitude, multiplied by sine. Sine of what? Sine of the angle between them. So AX and AX has the same direction. So the angle between them is 0. So what will be sine of 0? Sine of 0 is equal to 0. So therefore, this is also equal to 0. AX cross AX is 0. You don't need to put the direction because it's 0. So there is no need to put the direction. So AY cross AY is also equal to 0 because they have the same direction. Sine of 0 is 0. AZ cross AZ is also equal to 0. Then for AX cross AY, AX cross AY, this is not equal to 0 because it's sine 90. The angle between AX and AY is 90 degrees and sine 90 is equal to 1. So 1 times 1, so in that product, or here in cross product, 1, the magnitude is 1, and the direction should be equal to AX cross AY. So if we draw this again, the direction of AZ is the upward direction. Then this is AY, and this is AX. So AX, AY, and AZ. And the angle between them are all 90 degrees. So AX cross AY. So what is the rotation? So from here, and it goes there. So that is a counterclockwise rotation. So if it's counterclockwise, just like here, it's counterclockwise. So the direction of the cross product, the direction of the screw will be loosening or upward direction. So what is that upward direction? It's just equal to AZ because it's perpendicular to that plane, AX and AY. So this is just equal to AZ. And it's positive AZ because it goes upward. So if we inverse this, AY cross AX, then this will be equal to negative AZ because it will be in this direction, downward, because it will be clockwise. The rotation will be clockwise. Next, AY cross AZ. So if AY cross AZ, so this is the direction. So in that direction, it's again counterclockwise. So the direction of the cross product should be in this direction. And that direction is AX. It should be in that direction. It's loosening again. This screw is loosening, so it goes towards me. Then if you inverse this, AZ cross AY, it's the other way around. It's negative AX. It goes into that direction. Negative AX. This is negative AZ. Then lastly, AZ, or this should be Y. AZ cross AX. So X to Z. So X to Z. So that is in clockwise direction. So if it's in clockwise direction, what will be a z cross a x? So it will be in this direction. Or az cross ax. It's the other. This is ax cross az. So let's change this to ax cross az so that it will be in this direction. It's negative ay. Negative ay. So if we inverse this, az cross ax, this will be positive ay. So these are the cross product of the unit vectors, and this is very important when we are taking the cross product here. So again, we go here, ax cross ax. As long as they have the same direction, it's equal to 0. So let's just make all the same direction equal to 0. And this one is also equal to 0. And here, we have a times b, ax times bx, ax cross ay. What is ax cross ay? That's az. So the direction of this vector will be az. And the magnitude will be ax times bx. This is a by. This should be by. Ax times by. Ax by. Then another one, this one, ax cross az. What is ax cross az? Where is ax cross? It's negative ay. Negative ay. And the product is, so this will be negative ax bz in the y direction. Here, ay cross ax. So what is ay cross ax? Ay cross ax. It's negative az. So this will be ay bx az, but this is negative. Then here, ay cross az. Ay cross az. Ay cross az. It's positive ax. Positive ax. So ay bz ax. Then here, az cross ax. Az cross ax. It's positive. Az bx. And it's positive ay. Then here, lastly, az cross ay. Az cross ay is negative ax. So negative az by in az ay. Az cross ay. This is ax. Then we put them all together. The cross product will be equal to, we have ax, all ax, unit vector ax. So let's just factor them out. So where are our ax? Ay, az, this is ax. So ay bz. Ay bz. Then we have another ax here, minus az by. Minus az times by. This is in the ax direction. Next, for the y direction, we have negative ax bz here. But I want to put the positive first. Where is the another ay? Where is the other ay? This should be ay. Why is it ax? Ay, because this is az cross ax. Az cross ax. It's positive ay. So that is the positive. Az bx. Then we subtract the negative. Here, ax bz. Ax bz. And this one is in the y direction. Then lastly, for the z direction, we have again 2 ax by, the positive one. Ax by. Then for the negative one, this is the negative one minus ay bx. Minus ay bx. This is in the z direction. So this is now our formula for A cross B. This is A cross B. So it's more complicated formula. It's more complicated to memorize, but there's a way to memorize this one. So if you look at this, AX, if you have you are in AX direction, so look at the magnitude inside. There's no X quantity here. Okay. AY, you start with, because this is AX, you start with AY. You multiply it with the other one. So there's no choice. You cannot multiply it with BX, you cannot multiply it with Y again. So the other choice is Z, so BZ. Then subtract, you subtract the opposite of these two, which is AZBY. That's just the trend. If you look at all of them, there's a pattern. Here, AY again, there's no AY inside. So the next one, the next term from AY is Z, so AZ. Then what will be the magnitude that we will be multiplying with AZ? It can be A, it cannot be BZ, it cannot be BY because this is AY. So it should be BX, then minus the opposite, and so on. There's another way in solving this if you don't want to memorize. We can use the determinants A cross B. So by using the determinants here, matrix method, so we have AX, AY, and AZ. So this is AX because it's the first vector, AY, AZ, BX, BY, and BZ. So to solve for the determinant, you just copy the first two columns, AX, then AY. Then all downward is positive, all upward is negative. So downwards, these are you multiply the downwards. This one, multiply this one, and this one. So these are all positives. And these are all negative, the upward. So negative, negative, negative. So if we do that, this will be equal to, for the positives, we have here AY, BZ. So we have AY, BZ times AX. Then we have AZ times AY, or yeah, AY and BX. So AZ, BX in the Y direction. Then here AX times BY in the Z direction. So plus AX, BY. AX, BY in the Z direction. So these are the positive ones. For the negative ones, the upward, we have BX, AY, and AZ, or AY, BX, and AZ. And we have AZ, BY plus AZ, BY in the X direction. Then lastly, AX, BZ, AX, BZ in the Y direction. So if we simplify this, let's put all the components that have the same direction. For AX, we have your A, Y, BZ. And here at the minus side, minus, where is AX? AZ, BY. AZ, BY. This is in AX direction. For the Y direction, AZ, BX, positive one. And for the negative one, we have AX, BZ. So this is AY. And lastly, for AZ, here we have AX, BY. Then minus AY, BX in the Z direction. So if you look at this, it's the same formula that we derive here at the top. So you can also do this one if you don't want to memorize the formula, or you don't want to distribute here manually. So these are two methods. So this is a vector operation. In the next video, we will be taking some examples for the operation and unit vectors also, and it's all about vectors.